I'm going to show you a graphical method of solving simultaneous equations. Now this is a little bit more long-winded than the calculating method, but I actually prefer this because it all seems to come together right at the end. So as an example, let's consider our two simultaneous equations as this. Y equals 2x minus 1 and y equals x plus 2. Remembering that within simultaneous equations, the y here is the same value as here and the x value here is the same value here. Now, I can't solve these individually because they each have two unknowns in the equation. But I can substitute values into each of these equations and get corresponding y values for each value of x that I put in. And that's what I'm going to do now. I'm going to do each equation in turn, starting with the top one. And I'm going to substitute values in there. Now, the values that I choose can be up to me. I like to keep things simple, so I'm going to stick with 2, 4, 6, and 8. I'm going to put each of these into this equation and see what values for y I get here. So my corresponding y values, 2 goes in, 2 times 2 is 4, take 1 is 3, 4 goes in, 7 out, 6 goes in, 11 out, 8 goes in, 15 out. I'm now going to do the same for the other equation, and I'm going to substitute in the same values for x and see what I get out. My values were 2, 4, 6 and 8. Now this is an easier one. 2 goes in, so I get 4 out. 4 goes in, I get 6 out. 6, I get 8 out, 8 and 10. So I now have my two sets of coordinates. So I can plot these two sets of coordinates together on a pair of axes. So, remembering that my x-axis is the one which goes across, so therefore my y-axis goes up. 2 across, 4 up will give me the point here. 4 across, 6 up is here. 6 across, 8 up is there. And 8 across, 10 up is here. So I can now join those together as a straight line. So if I now take the other equation, which gave me these coordinates, and plot it on the same axes, let's see what we get. 2 across, 3 up, which is a point here. 4 across, 7 up, which is there. Let's move this down a little bit. 6 across, 11 up, 6, 11. Now I can't actually fit this coordinate on because it goes to 15, but it won't matter because I can see my two lines do actually cross. So the point now where these two lines intersect each other is actually the point at which the y and the x values satisfy both of these equations. So this is one of the best bits where the penny seems to sort of drop. Here we can see that x is equal to 3 and y is equal to 5, and that works for both of these equations in this example. I hope that helps.